I would like to welcome you for joining for this meeting. My name is Olivier Salvi. I am the coordinator of the DIREKTION project, and I will be moderating this webinar, which is the first one that we organize in the framework of the DIREKTION project. And I would like to introduce the speaker for this morning. We will have Vitor Reis from the Escuela Nacional de Bombeiros, so the National Fire Service School in Portugal, Cecilia Amar Wichmark from the Western Norway University of Applied Science and the Swedish Civil Contingency Agency, and the two colleagues from Crisis Simulation Engineering, Eric Maran and Victor Montalvo, who will present their solution, demonstrate the technology they provide for virtual reality, augmented reality for the training of first responder. This is the topic of our webinar today. And so in terms of agenda, we will have first some introduction about the context of the organization of this webinar, speaking about the stakeholder hub of CMINE DRS, as well as a short introduction of the DIREKTION project. Then regarding virtual reality for training of emergency responder, we will have the emergency responder perspective with Vitor Reis. And then Cecilia will present us the research perspective and what are the innovation and new development in this domain. After this presentation, we will have a demonstration that will last about 20 minutes of the solution provided by CRISE, so the company of Eric Maran and Victor Montalvo. Then there will be an opportunity to have some interaction, discussion, question and answer with a participant, with a panelist, and at around 12 o'clock in Europe, we will stop this webinar. So let's start with some introduction. As I told you, we are organizing this webinar in the framework of an initiative which is called the CMINE DRS Stakeholder Hub. This initiative is a way to put information about project results, about information about disaster risk management in a place which is the DRS stakeholder hub. So if you use the QR code, you can then access this place. To further describe the concept of the DRS stakeholder hub, this is a place where the projects that are working in the field of DRS, disaster resilient society, where they can provide their legacy on a single portal, a single web page, where you will be able to find information even after several years after the end of the project. But it's also during the lifetime of the project, it's very useful to have this one-stop shop where you can have all information you need about the ongoing research in the field of disaster risk management. So this is, I invite you to visit this website and find relevant information for you and for your activity. Let's continue with a short introduction of the DIREKTION project. So this is a network, so-called Disaster Resilience Knowledge Network, which objective is to promote innovation, technology uptake, and to stimulate the cooperation between different stakeholders involved in the development of innovative technology. In the project, we are working on the identification of needs, identification of gaps expressed by emergency responders. Then we are doing some screening of this of potential solutions that answer the needs of the responders. And finally, if there is no solution available, we recommend some future development and work closely with the European Commission for this purpose. And we try also to bring together the emergency responder with the solution provider, researcher, so that we are able to develop the solutions that are needed. So this is in a nutshell what I can say about the DIREKTION project. I invite you also to visit the web page, and at the end of the project we will have a set of procedure, a set of tools that help for the identification of gaps, identification of solution and assessment of solution, as well as dynamic network with the exchange of information. And we are working hard at the moment with the partner of the network, in particular with CTIF, the International Association of the Firefighter and Rescue Association, as well as the European Federation of Firefighter Officers, FEU. So we are working with the emergency responder participating in DIREKTION to make sure that all what we are developing in DIREKTION will be used after the end of the project. So thank you for being with us, and I would like to give the floor to Vitor for the perspective of an emergency responder.
Okay, thank you. So good morning, everyone. My name is Vitor Reis, and I work at the Portuguese National Fire Service School. We are partners of the DIREKTION project, and we have been working with virtual reality technologies for the past 10 years for training of firefighters and also civil protection agencies. So today, I would like to share the perspective of emergency responders on the role of this technology in training. I will talk about why VR matters, where it's already proving its value, and what's holding back wider adoption, and also what we expect in the near future. So for starting, why VR matters, we all recognize the rising complexity of emergency situations and the high performance expected from responders. At the same time, emergency services must maintain a constant state of operational readiness, even for rare but high impact events. This is more and more difficult as traditional training methods become more expensive, riskier, and less capable of replicating complex emergency conditions. As a result, there is an increasing need for training solutions that are safer, more cost-effective, and better equipped to simulate the challenges of real-life emergencies. So this is where virtual reality comes in. While VR is not a solution to all constraints, and even the most advanced systems have limits in realism, it offers an effective solution for training. The key is to focus on where VR truly adds value, and it is as a complement and not a replacement for hands-on training. VR allows trainees to experience scenarios that are too dangerous, sometimes too rare, or too expensive to recreate in live exercises. Mistakes can be made in a safe way, and trainees learn in a controlled environment. Because scenarios are digital, they can be reset and reused as often as needed, and they are not affected by weather, location, or even resource constraints. This capability to repeat scenarios, improve skill development, ensures consistent quality across training courses, and also supports fair assessment. It's also important to recognize the expectations of younger generations who expect to engage with technology throughout their training. VR's effectiveness is supported by decades of research across different professions like aviation, medicine, and the military. The question is no longer whether VR works, but how to best integrate it into training activities. So next slide, please. Let's look at some of the key areas where VR is already making an impact. Is proving effective in incident command training. Simulators allow incident commanders and command teams to practice decision-making, communication, coordination, resource allocation in complex scenarios, something that would be impossible to replicate frequently in live settings. Emergency driving is another area. Driving under pressure, through traffic, and in unpredictable conditions is a serious challenge. VR provides a safe, controlled environment for practicing responses to high-risk driving situations involving fire engines, ambulances, or even police cars. Fire investigation training. Well, VR replaces the need for controlled burn scenes, usually made in containers, which are expensive and not friendly for environment. With this technology, trainees can explore virtual post-fire environments, analyze clues, and practice identifying fire origins without needing physical setups. VR also supports medical emergency training, particularly for mass casualty incidents. Trainees can assess multiple virtual patients, make triage, and make treatment decisions in dynamic conditions. These examples show how VR can reinforce training across emergency services. And that's just part of the picture. VR for firefighter skills training has also grown thanks to new immersive systems that integrate not only visuals and audio, but also haptic feedback. Next slide, please. So what's holding back wider adoption among emergency responders or organizations? Well, a key challenge is organizational resistance to change. Some services and training organizations are unsure whether VR fits into their current training programs or even question its value. Others simply prefer traditional training methods. Practical barriers also exist, lack of infrastructure, limited funding, and insufficient technical capacity can also slow or prevent technology adoption. Overcoming these barriers means to have a clear understanding of the training needs and align VR with organizational goals. It requires integrating VR into the broader training strategy, selecting appropriate solutions that meet operational requirements, and also involving instructors in the process. Do not forget that human resources also play an important role. Instructors must be trained to operate the system if that responsibility is assigned to them, or organizations must allocate technical staff to run it. Instructors also need skills in facilitation and debriefing to lead the VR sessions effectively. Some platforms may also require content developers to build or adapt existing scenarios. An advanced VR system is not a plug-and-play solution. It usually requires dedicated staff to operate it. Costs is another major consideration. VR systems require investment in powerful computers, big screens, headsets, and software licenses. However, while the upfront cost can be significant, organizations should also consider the long-term benefits. VR can reduce recurring expenses by minimizing the use of consumable materials. It can cut travel costs and limiting the need to take equipment out of service for the live exercises. And once implemented, it offers a scalable and a reusable solution, making it possible to train larger groups more efficiently and at a lower cost over time. Next slide, please. But these challenges are also opportunities, and lower cost and easier to use system. We believe that will help smaller organizations to adopt VR. Technology providers have to think about having flexible licensing plans, for instance, and just as important, is better support from industry to integrate VR into the organizational strategies for training, with tools, with guidance, and also providing some examples that help the emergency services to embed VR into their training routines. Looking ahead, VR industry should also focus on developing geo-referenced environments, simulations based on real-world locations can improve realism and allow trainees to practice in familiar areas, improving preparedness for specific risks, local risks, and also for the emergency response plans. AI integration is also something that we are looking for to enhance adaptability and making more scenarios more responsive to trainees' decisions, and also to provide some real-time feedback. It's not a matter of replacing the instructors, it's helping them to make their job. We also see great potential in adding predictive modeling tools, which are already used to simulate, for example, fire behavior in structural and forest fires, integrate them into VR systems, because these tools can improve accuracy and help trainees prepare for the dynamic nature of real emergencies. So we believe that these innovations can make VR training more realistic and also more responsive. And for concluding, my final words are, well, virtual reality is a fundamental part of training in the present, and we believe its role is set to grow in the future. It is not a replacement for traditional methods, traditional training methods, but a powerful complement that makes training safer, more effective, and more accessible. Thank you for your attention, and I look forward to your questions and the discussion ahead.
Thank you so much, Vitor. I think it was very informative to have this global view of in your school with some long experience on this technology. So thank you so much. And yes, I'm sure there will be a lot of questions during the Q&A session that will be after the presentation by Chris. Now I would like to go ahead and invite Cecilia Hammer-Wichmark to give the research perspective, the research insights.
Thank you. Thank you for inviting me to talk in your really interesting webinar. I'm excited to be here and to give you a glimpse of my research and also to learn about your experiences and discussions. Just some quick words about me. I have worked 20 years in the education, training and exercises for fire and rescue service in Sweden at the Swedish Civil Contingencies Agency, MSB, who is responsible for the 2 fire colleges in Sweden. I've been a manager of the technical department responsible for the training ground, facilities, equipment, IT, and at the College of Sande. And during these years, I've also been involved in several different research projects. But now, since 5 years ago, I'm a full-time researcher now at the University of Skövde. I was at the University of Applied Science in Norway, but now in May, I switched to Skövde in Sweden. My academic base is in computer science, and my research interest lies in the use of technology to supplement and also in some parts enhance practical training and exercise within the context of fire service. The focus is of course on the technologies, but it is as much on the acceptance, the values, the cost benefit, the training effectiveness, and the implementation of these in the organizations to actually reach the intended and expected values. So within these minutes, I will touch upon one part of my research, which is related to the incident commander training using virtual simulation. I will have to say something short about the incident commander and his role and the importance of practice-based training using simulations. And then I will go into my research in one way to evaluate the VR training, and that is to investigate the trainees' sense of presence in the training. And I will focus on this perspective in this presentation and give you a snapshot of some research results. So the incident commander, this is the individual who is responsible for leading and coordinating the response to an incident. That is really clear, but the individual is expected to do this in any incident called to. He or she will be the one who knows what to do, who mitigates the consequences, make sure to save lives, also to use the resources efficiently and wisely, and be professional in all this stressful situation. And this in the range of fires, all kinds of fires, traffic accident, hazmat incidents, floods, wildfires, you name it. And how do we really train train people for doing this job? And how do we maintain their competence and develop this competence? Of course, theoretical knowledge is a basic, but we really need to provide practice-based training where the person can take on the role in realistic scenarios. That is, taking on the role with all that it's included and is expected in this role during different various scenarios to make this person really prepared to take on this job. With realistic scenarios, that is that we want to include natural aspects of the scenario. For example, risks, dynamics, the duration of a scenario can matter if it's a quick one or a longer scenario. Relevant ingredients, talking to people at the scene, leading the firefighter team, collaborating with the police, emergency medical services, and others. That is what I mean to train in the role in a realistic scenario. And what does this really require from the learning environment? What is necessary and what's only nice. The more we know about this, the more efficiently we can choose and adjust the learning environments and the activities, and you will be more able to choose and compare virtual reality solutions. Here today, we will focus on the incident commander training in virtual reality, whether it's on screen, a big wide screen, a smaller screen, or a head-mounted display. I guess you have all seen the format of training in this sense in somewhere, and these kinds of setups. But often the question rises if it's realistic enough compared to training formats like live simulation on the training ground, where you can use real fire, real building, real people, trying to compare it. And that's what Vitor also touched upon. It's not really about removing that, it's how that can be supplemented. What can VR actually add or supplement the traditional training on the training ground? But others also might question if VR training is really adding any value worth the cost compared to just using pictures and animations. And this is where my focus, the focus of my research has been, trying to find out the role of VR training in this whole context. So within VR research, we look at the concept of presence. This is the trainee's sense of being in the situation, acting in the role, doing the task, recognizing objects, interpreting the situation, communication with others, collaboration with others, moving freely at the incident, naturally in the role, not performing a good exercise, but really performing in the role as the incident commander. The sense of presence is related then to the concrete experience, like core experiential learning and the application of knowledge in a situation, Bloom's taxonomy and so on. But the presence here can be measured in a systematic way, evaluated by questionnaires, observations, and interviews. And we have developed a battery of questionnaires and observation tool for doing this. And it's all about the experience of being there, the experienced realism, compared to in simulator training, for example, flight simulators. You look at the fidelity of the simulation and the exact graphical representations. This is more about the experience of it. We have performed many studies in real training settings. This is not in a laboratory or in a university setting. It's in collaboration with training organizations. We have looked at what contributes to presence and what hinders and limit presence at the trainee perspective. And this has to do with the graphics, 3D representations, audio screens, whatever. The presence experienced in relation to live simulation and in relation to real incident situations. In the end, this is a matter of training effectiveness, how to reach the learning goals, and the cost. Where should you put your money when you choose the VR technologies? And some results. For sure, as Vitor said, it's not a question of using VR or not. It's here to stay. The willingness to train more in virtual simulation is above 95%. And that is compared in relation to other training formats. They want more virtual simulation training. The experience of this presence is high to very high in the majority of the participants compared to live simulation, and also very high compared to real situations. We saw that low experience of presence was related to low performance. That is, the individuals that was most insecure in their incident commander role and had least experience previously, they also experienced low presence. But they were also the ones that performed lowest in other training formats. The majority found that they could move freely and perform their tasks as they wanted in the virtual environment, but 7% had issues with learning how to use the game control or moving. But this was also connected to the insecure ones. But at the same time, these insecure ones are the ones that need the most training. So here we have something that we can focus on to put some extra effort into how to teach them how to use the simulation training, but also maybe enhance the input controls. About the realism of the fire smoke representation, the behavior, and the realism of the avatars, their movement and interaction, it's good enough as it is today. It's nice to improve, but it's not necessary to put even more effort into the details of the fire for this kind of training. And we had some really interesting comments. But I don't know the time, but if I just can make some short recommendations here, is that from this research we can see that focus on the learning objectives, the learning activity, and what do this require from the technology. What is it required that the student can do, see, act, and what does that require the technology to do, and explain this to the technology providers, because they cannot know. Not the other way around. If you look out the window and look at all the technologies out there, you can easily drown, and you can find so many fancy technologies, but then you have to put a lot of work in how can this be used within your organization. If you know more about what you're really looking for, then it's going to be easier. And also for this, I've used studies, small studies, bigger studies, to evaluate learning activities using virtual reality in different kinds of ways. And in each perspective, this is a step in the implementation to try out, design the training in connection to your learning objectives, and try it out within your organization. This can be done in a project, and it doesn't require you to purchase any technology at first. You can just hire it, hopefully often, and then you can conclude what you really need and what values this adds. This is a pedagogic step within the organization. It helps implementation, and it also helps the motivation of the investment. And I think I have run out of time.
Yes, thank you, Cecilia, for your very enthusiastic presentation. We see really that this brings a lot of added value for the training of the officer, and to have a diversity of solution, a diversity of situation. I mean, this is very powerful. You have some in the chat. There are, or in the Q&A section, there are some questions for you. We will take after the end of the presentation from Cries. So now I would like to move to the presentation by Eric and Victor about the solution provided by Cries. So I suggest you start sharing your screen.
So I'm Eric Maran. I'm the CTO of Cries. Okay. Cries is a company that's been created back in the end of the 90s. Just to answer a few points that's been raised by Victor and Cecilia, we adopted VR back in the late 90s. We started working with VR because we thought, and it's proved to be right, that it enables to improve soft skills and to share these skills with participants. It increases learning effectiveness and retention rate. It allows a high level of emotional connection to the content and to the team that we are working with in VR. It allows to develop more confidence in what is being taught. And this is very important, that the trainees are experiencing more confidence when they are living a training. It creates less distraction and more focus than live exercises. And most of all, no injuries. It has to be kept low cost, of course. No fire equipment wearing, toxic exposure or pollutions. And these are the main points of using VR from our point of view, and that will be used as a screen for future and technology expectations, as Victor has pointed out. So, as you know all, wildfire is a large operation that involves ground teams, air teams, coordination, commandment, working all together. Back in the late 90s, Valabre, French National Risk Academy, had difficulties to train officers to wildfire because of the difficulty to establish a pedagogic frame around a complex operation. At the time, commandment training in Valabre was only theoretical. People were imagining fire in the classroom or scattered over a large area on the field during costly deployments without air, without helicopters because it's very expensive, or were gathered around some tables trying to pretend that they were seeing things and making reports about color bits of wool on the sand. So we started working with Valabre for 2 years, and we designed a tool that enabled to train all levels of commandment together, from the crew officer, from the crew leader, up to the incident command post, and even strategic level if needed. CRIS originated from GIS software development. So we were, back in the 90s, able to reproduce large environments in 3D and represent operational information on this 3D, because 3D allows the level of understanding that is needed to understand a situation, a tactical situation, and hence enhance situational awareness for everybody, even for people that are not fire officers like the mayor, like other people that may be taking part into the incident management. So this is, I'm sorry for the sound, hope it doesn't pollute. So here we have an example of the tool that we developed. As you can see, people are driving their trucks. What's important here is that the environment has been created by the user. It's completely geo-referenced because it's been created from geographic information system, and designed by the user because we think it's very important that the user is able to manage completely all his pedagogic assets. So it's a network application where everybody participates to handle an incident, here wildfire, under the control of an instructor. So here's the instructor. He defines the weather conditions. He defines the starting point for the fire, and then the fire evolves freely. There's a predictive simulation of the wildfire, and it's a pedagogic one. It's not an university one, or university tends to need very highly detailed database. And operational models tend to integrate time and space to predict the future. In our case, we want a real fire in real time, taking into account the actions that will be led by the trainees on the fire. Okay, you can see that he's using his map, a classic map, because the map is the origin, the cartography is the origin of the reconstituted area. So everything is your reference, everything is real. Sorry, I just stopped the film, so I'm starting back because I still had things to say. Sorry for this. So you see the model reconstructed by the user. You see the fire propagating, you see the group in actions, and I can't go faster because I don't have the video control. So we see again the instructor, sorry for that. And then we'll go to the ground crews. Yes, the crew commander are experiencing the situation from their own point of view, and they are proactively seeking the point of view they want. They are choosing the equipment. Here in wildfire, it's not the case, but in industrial environment or whatever, they will be able to choose their PPI, their protective equipment, measures, sensors, whatever. You see that he's using his map, and you see that using 2 radios to communicate with up and down channels of commandments. So in an exercise, you may have helicopters involved. Helicopters can participate to the fight. They can extract victims and offer a lift to the commander, or air attack too. It's important to know that in Valabre, in the case of Valabre, the pilots are instructors. They are here to practice air-ground coordination and air-ground and safety rules when that is involved in air-ground operations. Okay, all this to the benefit of the incident command post. So the incident command post is not using any fancy 3D environment. It's only using its usual tools. You receive inputs and information from different crews on the ground, different people on the ground, from the air, from the phone, well, like it happens in every operation, have to consolidate an idea of the situational awareness as a team, because each one has an idea at the beginning, but at the end they need to process this as a team. Then elaborate strategies, do anticipation, elaborate strategies, and give missions to the ground teams or air teams. So we are reproducing a commandment loop where the incident command post is looking for information, is giving missions, and the ground teams are providing this information to the incident command post, and we have this loop created. So that's one of the interesting points. For the unseen commander, or for specific times during training, we are using, well, the Valabre is using headsets displays because it's interesting for the first unseen. It's interesting for the first unseen, yeah, which is not a higher rank officers usually. It's interesting for the air officers to manage planes, to guide planes over the incident. And it's interesting too for the on-scene commander when he wants to really feel what it's like. And it's interesting to do stress tests too in this very immersed environment. Okay. Of course, it's important to do debriefing, okay, and to take the lessons learned of the exercise afterwards, and we have plenty of tools to do that. Okay, so this was the start. Back in year 2000, first kick of the simulator, it needed 40 computers to run the simulation for 12 to 20 trainees at the time, and now it's much less, but we started with Valabre, and then we started to distribute our system to other academies, mostly French National Academy of Firefighters Officers. And then the second time we go down to provincial levels and operational task forces, because the structure can be light enough for operational task forces to use. Then to infrastructure managers, airport, harbors, rail, underground, military. We're working with the warship damage control. Industrial, of course, we're working with Total, Chevron, and other majors in the distribution of in the energy sector, of course, offshore, onshore. New energies, we've been working for hydrogen in the Risques project a lot, and industry, of course. Then a lot of education, colleges and universities are starting to use our tool. École des Mines d'Alès in France, or college levels, okay, to train future managers. Okay, beside the type of clients, we've been expanding to our risks palette. So we started with wildfire, as you can see. Then we worked for floods, low and high energies, floods, tsunamis, even urban risk, all kind of urban risk. And interestingly, for New York Underground Transportation Association to train the 9/11 call and dispatchers, working for religious inheritance preservation and shrine, started to work a lot for technical and hazmat, of course, petrochemical, as I said. Interesting thing, we're working in Taiwan for semiconductor etching because it involves very toxic chemicals in Taiwan. We're working with Andra for nuclear waste storage planification. Working on CBRNE, counterterrorism, and combat USAR lately. Our tool has been used to train the bomb disposal squad in France. It's been to use for special forces in incidents like hijacking of the Seveso site, where all firefighters, private and public, and special forces have to work together, for example. Been involved in large incidents, multi-institutional response, terrorist attack, dirty bomb, 60 participants at the same time on the simulator. We even developed a field hospital management for field hospitals training for French escrime. Another evolution has been on the different setups. Of course, the one-to-one to train incident commander is one setup that is possible. Individual training, solo use is to training. We will see some example afterwards. Classroom tabletop training is another use of the tool. It's very interesting to have a tabletop where we can propose and do errors and go back to see what happens when you make an error and go back to the previous situation. Full-scale training, as we've seen with Valabre, including multi-institutional training, and all this can be on static installations or can be done on mobile training, distance training, multi-site training with the application hosted on the cloud. So here it becomes really training on demand since it's always available on the cloud and there's no specific investment to keeping things up. Here we've got an example of a 360 pictures used for solo training. Here the user can freely move from bubble to bubble, can take first actions, choose his protective equipment, and perform immediate reaction to an incident. So this is easy. This is an incident commander training on a farm environment. Always the environment is done by the client. And here we have the IC and the ICP working together on understanding what happens and trying to get an operational picture and managing the incident. And this illustrates the animation team work. We see the number of animators. As Cecilia pointed out, the real voice and the presence is really, sorry, I'm going to stop because so the real presence and real voice are very important to ensure presence and emotional engagement in the incident management. So we present you some tools for managing the animation team and afterwards. Here we see setup in Valabre, which involves a distance simulation. So we have a single place in Valabre, and we have the trainees, the incident command post, and eventually other. Yes, here we have an observer or a trainer, maybe a trainer. Yes, technical management, here the trainer that are participating remotely. And the pedagogic setup here is very important, so we can talk about it. So these are different setups. But here we have VR training on demand when it's used on this way. Here it's an older setup for naval damage and control used by French military, but you see the different team managers that are managing the incident together. So this is the global concept of Eve. Eve enables the user to import his 3D data. 3D can be anything from GIS data, CAD, BIM, architectural, or produced by freeware on the internet, like My House in 3D or Chief Architect or whatever. All are able to export in the normalized 3D format that we're using. Google Map, for example, Google Earth is able to produce environments and can be enriched by the user, by the end user. So you're importing your 3D and you create the environment. Then you compose what will be the incident. So the Eve tool is supporting open-ended scenarios, so only the initial conditions are to be defined, or completely closed scenario where you can prepare all the different branching of a closed scenario and manage them. You can spice it up with some animations or some injects that are coming from logic and specific tool through the wire interface, and then you train. What is important is that everything is on the very same application with the same functionalities, from importing, composing, animating, and playing. Everything is done in the same interface. And it's possible from this scenario creation to elaborate. So on the lower left, on the image on the lower left is the petrochemical guy managing a training simply with a push button interface. On the right, on the bottom, you have a technical operator that manage a wildfire, a complete wildfire exercise. On the lower left, you have this guy is managing a petrochemical industry exercise simply with a tablet. It doesn't need any 3D expertise to do the training. Okay, so this is the kind of tool we are making available to our clients to lower the usability cost of the VR, because it's very important to lower the cost. Victor's been talking about real environments, georeference and real environments. These are a few examples of digital twins that our clients use. This is the IRI building of Marseille. It's been designed for BIM data, which is architecture produced. Lots of floors, including an underground computing center, shops, and even a disco on the first floor, rooftop with restaurants. Okay, fully workable with smoke ventilation and fire equipment. This is Chambéry in the Alps. It's a city center. It's a medieval city center. It's a dreadful area for firefighters. They fear an incident or a collapse, a structural collapse of this place, because it's very complex. You can only enter through small corridors, and it's a walled city center that is designed like this. So we reproduce all the city center. All apartments are accessible. All windows and doors functioning, ready to burn or crumble if earthquake. This is a Paris suburban area, reproduced from available data in the firefighter centers, and you can see it can be night, can be day, and it's ready for any kind of exercise you want to compose in this environment. Okay, I think I eat up of all my time, so Oliver didn't talk too much, so I will.
Yes.
I will stop here. I've got plenty of other things to say or to share, but I will stop here.
I think the mission is accomplished, and I would like to thank you, Eric, and with your colleague Victor and the team of Christ to share this experience and to show the diversity of situation that reality can offer. So I think it was very informative for all of us, for all participants, to better understand how it works. What is also very interesting to see is you can have different level of training and different organizations. So solo training or up to mobile training, and with people located in different places. So it's very useful to see that it is very flexible. So thank you so much for sharing with us. I would like to start the Q&A session, and we keep your picture on the screen, and I would like to read the questions that were addressed to Cecilia, and then there is a question to you, Eric. So the question to you, Eric, and I give time to Cecilia also to look at the question. So the question to Eric is, how do we translate the training content into VR ready content? So how to come from a usual training to a VR training? So maybe you can elaborate your answer. And two short questions to Cecilia. The first one is it possible to share the battery of instrument you mentioned during your presentation? It's a question from Lynn Hulse. And the second question is, where can one find your studies you mentioned during your presentation? So maybe, if Cecilia, if you can say where we can learn more about your work and where we can benefit for the battery of instrument you mentioned during your presentation.
Okay, yes. The battery of questions and observations is not published yet, but it's part. I mean, you can see it in the published articles that you can find. Just Google my name on ResearchGate or in the Google Scholar or somewhere. You'll find different articles. Use the word incident commander. There are some research also on VR for firefighter skills training. But the battery as a complete framework will be published as soon as we have the possibility to do so.
Perfect. And so all your study, all your work is available on the ResearchGate, as you said.
Yeah, it should be indexed, in the most databases too, and yeah, you can just Google Scholar is a good way.
Perfect. Thank you so much. I would like to come back to Eric now, and because I think the question is more for him. How do you translate training content into virtual reality ready content? What is the process to develop the scenario and to develop the environment? Can you tell us about this, Eric? Not sure Eric is with us still. So if Eric is not with us, maybe Vitor, with your experience as working in the academy of firefighter in Portugal, what was the process? How long it takes, and is it a big effort, or you are accompanied by the technology supplier, by the solution provider? How it works?
Okay, I can talk about our experience. So you can adapt the practical exercises that you are already using in your training to a VR simulation. Simulations have a similar structure, but of course you have to define the objectives, create the incident scenario, populate it, put resources, and define the events and the injects that you are going to use, and put them into an exercise timeline. So you can manage the simulation during the execution. You can also combine this with, for instance, role playing, which is something that we already use. So basically, first you define in your training the practical exercises, and then with some support, and the effort will depend, of course, on your experience. But it's possible. And in our case, we think it's easier to put it into the simulator and then run it for the students.
Thank you. So we see the process, how it works. So so I would like to repeat, because now Eric is again with us with Victor. How it works in practice from a training situation you would like to train people with, and developing the training using virtual reality or augmented reality. How it works.
Well, first the scenario has to be created, like for any incident. You need to know where you want to go. Then the user gathers free information. For example, let's say that you want to do a lessons learned. We have a client that only does lessons learned. Every month they are choosing a specific incident, and they are trying to elaborate a scenario corresponding to the incident. So they're using Google Earth to get, and Google Maps to get a bottom, the bottom of the situation, the ground. On this ground, we have a library of buildings, so they can start populate the 3D with buildings, and they can drape images if you want. That's the fastest and easiest way. You take pictures on the street and you're reconstituting your environment directly in the Eve product by drag and drop. If it needs to reproduce an interior, they will use a freeware on the internet that's able to recreate like my house in 3D. I don't know the one we're using. Sweet Home 3D, for example, they're using that enables to create with easily an interior, and they put it in the 3D, at the right place on the map, because everything is geo-referenced, and they record this and they can replay it during the exercise. Of course, they have to place the incident itself, the first beginning of the incident, for example, a fire or a urban incident or a pipe leak of gas or whatever they want to train. They've been doing a airport crash, they've been doing a railway incident and things like that. And then you can start to play. Just drop avatars in the 3D, firefighters avatars or policemen avatars or medics avatars, and you give the roles, and it's starting. And you can record this and as a VR film, let's say, animation, so that during the debriefing, it's possible to see what happened during the exercise from any point of view. It's not a video, it's not a film, but you can go back to a point in time, and if you've been looking on the right, but see, if you had looked on the left, you would have seen that there was a victim to take care about, and this, etc. So it's possible to replay, to do what if scenarios. That's it. Replaying the whole scenario on each connected computer, and start at a given time and try another solution to manage the incident. So it's pretty direct and easy. There's nothing more involved.
Okay, so it's not. Okay, so I think we have answered your question. So I think we have the feedback that our colleague Evert Rope appreciate your explanation. It's clear. We have last question. Is there any solution with VR and augmented reality solution for training? Yes, so there are several companies providing this kind of solution, and I'm sure that looking at on the in the network or in the literature, you have some different kind of solution.
Yes, but I'm not sure they are very interesting. At least not for commandment training. And we keep the screening I presented at the beginning of the presentation on the different interests of VR. And one was no cost, no deployment of equipment, no wearing, etc. Doing augmented reality means you need to set up physical support for augmented reality training, or you use real premises. You go to the opera and you take your helmet, your cask, your augmented reality display, and you see flames out of the opera. But that's it. It gives no more from the air, but you deploy the equipment. Well, it can be virtual, yes, of course, but you're in the street, you're polluting the environment. So a lot of cost is involved about the deployment. A lot of cost is involved because you need to move your computer, all the training setup on place. So we don't see yet the use of augmented reality, if not for using chemical sensors in a scene, or radiologic sensor to locate a radio source. Then having something in the hands with the display augments the feeling of presence, because you have something in the hand, but you can see only a virtual projection of the tool, but you need to have something in the hand to perform a source detection, for example, in radiology. But for now, okay. I will say with Cecilia that we need to screen the technology to the real use of VR on base. Does it answer? Yeah, my point of view.
I think it answers the question. And while we were preparing this webinar, I learned that there are different companies offering different set of tools. Some of them are enable only to extinguish the fire. Some other diversity of situation. So I think it's you need to select the technology that is useful for the training you want to deliver. I would like first of all to thank all presenters, Vitor, Cecilia, Eric, and Victor for the preparation and your contribution on this webinar. So this is the first that we have organized in the framework of the Stakeholder Hub, DRS Stakeholder Hub and Direction. So we plan to do more. I would like also to thank very warmly Bastien Caillard, who is working as project manager of Direction and who has set up these techniques to organize the webinar. And I would like also to thank all the attendees who remain with us during 1 hour and 12 minutes now. So we had more. This webinar will be posted on different web pages, different links, and I'm sure you will be able to share it with your colleagues if you think it has been useful, informative, and help you to better understand the benefits of this technology.
So I prepared plenty of answers for future questions, like plenty of things that I see in the future. So if anyone wants to carry on the discussion, feel free to contact us. Yeah. Okay. We'll be glad to answer you. Yeah, and you'll be exposed to long discussions, but it's another problem.
What we can do also is share with the participants some information and or post on the webinar web page this information if it is useful. Thank you very much. And so with these words, I would like to close the event. And again, thank all of you for your attendance and for your active participation. Thank you very much.
Thank you very much.
Thank you.
Bye-bye.
Bye.
Thank you.